Okay, we'll go ahead and get started. Thank you very much for attending, everyone. We're super excited to be here. We've got some amazing stuff to show you guys. I'm Christian Wade. I'm a Senior Program Manager for Analysis Services at Microsoft, and we are lucky to have Mr. David Jorgensen, Director of Strategic Business Analysis at Expedia, long title, joining us today. So thank you very much for joining us,
Happy to be here.
Okie doke. All right, so just as a quick refresher, you know, organizations have data all over the place in various formats and big data stores and data warehouses. It's very difficult for business users to access that data for consistent decision making. This is where Azure Analytic Services really shines, as we can define a semantic model over these large integrated managed data sets that then defines the user interface that business users see when browsing the data using business intelligence tools like Power BI, and this really just unlocks the value of that data for consistent decision-making in enterprise organizations, all right? And we're at the kind of dawn of a new era, so to speak, with Analytic Services. It's an exciting time for a product with a long and distinguished history. We're now a fully managed platform as a service in Azure with cloud scalability, high availability as part of the SLA, the ability to spin up servers in seconds rather than days, and this really allows organizations to focus on building quality business intelligence solutions rather than managing a bunch of servers and infrastructure. Okay, so I'd like to talk to Dave a little bit, since we're lucky enough to have him here. So Dave, tell me, what drew Expedia to Azure Analytic Services?
Well, basically speed to get the team ramped up.
Yeah.
Tabular is quick and easy. Plus, it integrates with Power BI so seamlessly. It just comes out to be a simple solution to implement.
That's beautiful, beautiful thing, beautiful. And so just tell me briefly, what's the data landscape like at a company like Expedia?
Well, it's numerous data sets, disparate, from Teradata to Hadoop to AWS. Sorry. SQL Server, bad words. But we've got data everywhere.
Data everywhere.
Yeah,
nice.
but Tabular allows us to create one semantic model and to create a single source of truth, which is absolutely critical for the business. So we have to have it.
Beautiful thing. And my last question is, how important is blazing fast query performance on Azure Analytic Services to Expedia?
Super critical. So we need analytics at the speed of thought. You know, we're a fast-moving company. I know, and Tabular is helping is helping us get there.
Brilliant, absolutely brilliant, Dave.
Hey,
thank you so much for joining me.
This guy, I want to say, this guy's a rock star. We wouldn't be where we're at.
Thank you so much, Dave. It's been a pleasure working with you on Expedia. I love coming to Expedia. I plan all my vacations for the next 3 years every time I go there. It's just awesome.
Keep on booking on Expedia.
Thank you so much.
Everybody.
All right, brilliant. Thank you, Dave. Appreciate it. Thank you. All right, cool. So this is Microsoft's business intelligence platform. I think it's fair to say that we're basically the only vendor that can really claim a strong presence in self-service business intelligence with Power BI and corporate business intelligence, which is typically owned and managed by IT with Analysis Services. We have a symmetric offering with on-prem and the cloud for Analysis Services, and as of this conference, we are announcing the much anticipated, much requested, much needed feature of imports from Power BI Desktop to Analysis Services. Thank you very much. We know it, you know it makes sense, you know it's awesome, so thank you. And this will really streamline workflows and really solidifies Microsoft's business intelligence platform, you know, with consistent modeling constructs and consistent calculation language constructs across both the camps. So if we're going to bridge the gap between self-service and corporate BI, it's useful for us to just take a second and understand the nature of the beast, so to speak. It's not always going to be as simple as just import from Power BI Desktop, right? So self-service BI is typically characterized by having a large number of small models. Doesn't mean all of the models are small. We've now got Power BI Enterprise. But statistically, we're empowering the analysts to create lots of models quickly and easily in an unconstrained way without a dependency on IT. Corporate BI, on the other hand, is characterized by having a small number of large models because we want to promote reusability, we want to promote data governance, we want to promote efficiencies around the management of data, we want to promote data consistency and data quality in an enterprise organization. So the real challenge here is how to strike a balance across the two camps, right? So I've heard it referred to as the third wave. I've heard it referred to as BI for everyone. And I'm hearing this more referred to as bimodal BI now, which is simply allowing the business and IT to work in harmony. That's the real, secret sauce, so to speak. This is what organizations who are going to be successful in this area are going to achieve, right? So I've got a Gartner paper here that observes that centralized teams can identify the most successful work being done at a local level and provides a platform to share and promote this work globally. As I say, it's not as simple as just import from Power BI Desktop. We need a process, a predefined process that will harvest these insights from self-service BI, put them through the necessary level of rigor to then be promoted to corporate BI for wider distribution in an enterprise organization. And I'm going to be the first to admit that this is an organizational problem before it is a technology problem. However, it just so happens there's a company that happens to be called Microsoft that has an end-to-end modern business intelligence platform that spans both the camps, that now has a seamless migration path across both the camps, which will ultimately accelerate these workflows and result in business agility. Okay? So this is going to be the demo architecture. I'm going to start off with a corporate BI model in Azure Analytic Services. This is a big model. There are over 10 billion rows in this thing. This is about 9 terabytes of data in its raw, uncompressed form, like in the CSV files. And for a data set that size, which is coming from SQL Data Warehouse, we need a process to manage the data refresh, right? Just like a data warehouse, we're not going to do a full refresh every day. We need a parallelized incremental process, which is running from Azure functions, not from a virtual machine, so that we have this end-to-end platform as a service architecture. We will then take a Power BI desktop file that happens to have a reference to a data set in Azure Blob Storage, and we will integrate that model into the existing corporate BI model and thereby create a new data source to the Blob Storage. Now, the reason we're integrating it into the same model is, again, because we want to maintain a small number of large models for reusability, right? We're typically, we're not typically going to have a separate database for each migration from Power BI. Otherwise, we'd end up with lots of databases. So we want to have a small number of large models for reusability. So that's the idea. Okie doke. So let's jump into the demo. Most of the rest of the session will be a demo. And then I'll summarize what I've showed you. Okay, so this is the taxi model. It's actually the same model that was used in the keynote, except this one actually has 10 billion rows. And so and this is real data. It's just been exploded a little bit to show off the scalability of Azure Analytic Services. So I'll go ahead and drag in trip count, make that a card. There we go. That's the 10 billion. And one of the cool things in Power BI Desktop now over Analytic Services is that we can create our own report level measures, right, which really gives the user the flexibility to create measures to support whatever train of thought they have at that time. So we'll say revenue over trip equals divide revenue by trip count. Okay. So just like that, we can create a measure, which is a brand new feature that we didn't have. And if I just find it and drag it over here, we can break it out by the top 10 zip codes. There we go. And so you can see that it's blazing fast performance on a massive data set, right? 10 billion rows. As I say, it's about 9 terabytes in its uncompressed form, just instant gratification. I like to call this clicky, clicky, draggy, droppy data analysis, right? I just clicky, clicky, draggy, droppy over these massive data sets that are owned and managed by IT, and I just get instant gratification, just like that. I've been in America that long. All right, anyway, so, so I now want to break this out by the map, of course. We like map visuals. And there we go. There we go. We've got some amphibious taxis there. And we get the lovely cross-filtering behavior of Power BI. And then we can zoom in, and we can, of course, go from the 10 billion aggregated value all the way down to the individual pickup locations, which happen to be on the freeway, because people run off the plane and run out in the middle of the freeway, which is all a little bit worrying, troubling. Maybe we'll correlate this with some accident emergency data one day. Anyway, the other one is, of course, well, that was JFK. The other one is, of course, LaGuardia. And, of course, we have the same problem with LaGuardia. And interestingly, they're all on the outbound carriageway of the freeway, which just shows that they're that keen to get out of there as quickly as possible. All right, so that's the corporate BI data set, so to speak. So how do we manage a data set of that size? So first thing we do is we use partitioning, which is an analysis services feature. And I've got about 120 partitions in here, one for each month. And one of the really interesting things now is that if I look at the query statement, this is not a native SQL query like we used to have in previous compatibility levels. I'm just going to call out that this model uses the 1400 compatibility level, which is brand new. It's going to ship in SQL Server Analysis Services 2017, and it's already in Azure Analysis Services. And with the 1400 compat level, we now have the M and Power Query integration, which is why this is now an M expression, which is just is going to be a game changer from the perspective that this gives us an extra level of abstraction over the data source. Is going to give us some just the flexibility to do mashup capabilities, which I'll actually demo in a moment. All right, so I've got 120 partitions in here. Guess what? I'm not going to create all of these by hand, right? In fact, it's more than just the creation of these. These need to be managed. So maybe a couple of times a day, I'm going to run a process which will maybe refresh the last 3 partitions, which are the ones where the data can change. And if I start a new month, I'll create a new one, and I will lose the partition from 10 years ago, say. So I need a process that's going to manage that. And there is a code sample on the Microsoft Analysis Services Git repo that you can use, and it's all configuration driven. There's a configuration database, and that's what I'm using here. And I'm executing that code from Azure Functions, and I'm scheduling it from Azure Functions as well, using the cron expression format that we have here, so that we have this end-to-end platform as a service architecture. All right, so this is one of the kind of features that you would expect for corporate BI, is this granular partition management using an application programming interface for that. All right? There are lots of other features that I'm going to show you for things like advanced security, advanced modeling, application lifecycle management, deployment processes, advanced calculations and monitoring, and those types of features are what you would expect. I'm now going to pause for a moment on corporate BI, and I was going to say take a taxi ride to self-service BI land, but they're now so close that we don't need to get a taxi. I'm going to switch over to self-service BI land. And here I have a self-service embedded model that happens to have, in this particular case, it's just a simple one. It happens to have a weather data set that a user is getting from Azure Blob Storage. All right, so this is the data set here. And I want to harvest this and integrate it into my existing corporate BI model. All right, so first thing I'm going to do, if I just close out of there, and we'll switch back over here, and we'll say add, and this is the new web experience for Azure Analysis Services. And I'm going to say weather import, choose the file, and we'll just let that load in. So just to recap, I'm just taking that model and I'm creating an Azure Analysis Services database that is going to have the imported model, right? There is a way to get back the PBIX file with just the report without the embedded model. And this will be available to you guys in the July timeframe in a preview with a limited number of data sources initially. And then from here, I can now view the model metadata in its JSON representation. And I get some level of IntelliSense here as well, which is all great. So I've got this model into Azure Analysis Services. It's its own little database in Azure Analysis Services. And in many cases, that might be what I need. I might just keep that database and start managing it from there. But as I said, in many other cases, I'm going to want to harvest those objects and integrate them into an existing corporate BI model to consolidate and maximize reusability, right? So any guesses on how on earth I'm going to get this model here into the taxi data set? Any guesses? No guesses, not even from the people that know me. Thank you so much, Chris. Thank you so much. So I think it's fair to say, at least I'm not aware of any other business intelligence vendor that has schema compare for their business intelligence models. So we have a tool called BISM Normalizer, and you can access it by going to Tools, Extensions and Updates. Here it is. And the easiest way to get it is to just go to online, and you can type in SSDT. And as a side tip, this is actually the quickest and easiest way to access the analysis services extension for Visual Studio, the SSDT extension that we run here in Visual Studio, and we get all of the source control integration and hooks into DevOps processes, etc. So you can also access BISM Normalizer this way. The source code of this is on the Microsoft Analysis Services Git repo as well. The guy who created it is some guy called Christian Wade. He happens to have the same name as me, but that's OK. Don't worry about him. Anyway. All right, so now that I've got everything set up, I'm going to go to Tools, New Tabular Model Comparison, and I'm going to specify the source from that same new database that is on a test cluster. There are those two databases, and my target in this case will just be the project here in SSDT. And in this situation where I'm harvesting objects from one model to put them in an existing mature corporate BI model, there's going to be a lot of stuff in the target I don't want to mess with, right? So there are going to be a bunch of these items with a delete action item that I want to skip. And I can do that in one go by selecting skip all objects missing in source. They all get skipped. I can now say hide skip objects. We can focus on what we're going to actually bring into the taxi model. So we've got the Azure Blob data source. We've also got another SQL data source here that for whatever reason we're not interested in. So this will be quite common as well. We just want to harvest the nuggets that we're interested in. So we'll go ahead and skip that data source. And we've also got these date calculated tables that are hidden in Power BI. And these are created in Power BI Desktop to provide date hierarchies for the users, and they're hidden. But since we're going to be integrating this into an existing corporate model that already has a date dimension that's on top of a data warehouse that already has a date dimension, we don't need these, right? So I'm going to go ahead and just skip them. Skip. And now I can say validate selection, and it's going to tell us what it's going to do. And it's also going to tell us what it's not going to do. So it's telling us it will not create the freight M expression, which is here, because it depends on the SQL data source that we chose to skip, right? And similarly, it will not create the freight table because it depends on the freight M expression, and it won't create a couple of relationships because they depend on the hidden calculated tables. So this dependency analysis, this is what makes this tool usable, right? Because this is what makes any schema compare tool usable. This is what allows me to say, click on generate script and hand this script over. This is the scripting language for analysis services. I can now hand this script over to a DBA and be confident that it's going to run successfully, right? So we'll go ahead and update the target model. And if we refresh, we should see that everything that we pushed into the target, like the Azure Blob data source, now has the same definition. OK, just go ahead and exit from there. Now we can open up the taxi model here in SSDT. We can find the new weather table, switch over to relationships view. And there it is. So we'll bring it down here. So you may be asking, would we not have put this weather data set through the data warehouse. And absolutely, we could have done that, right? And if we had done that, we still would have gone through this process to import from Power BI Desktop, to use it as a starting point, to bring in all the measures, et cetera. But in this particular case, I'm saying, you know what? This is coming from an Azure Blob data source. This isn't a corporate sanctioned system of record with payroll data that's going to determine people's bonuses. I'm going to make an exception in this case, and I'm just going to pull it from the Azure Blob data source. And I think that's pretty reasonable in some cases to have some fringe data in your model that doesn't come from your data warehouse. So I now want to, potentially I could rename the tables and columns to make them align with my corporate naming standards. And I need to create some relationships. So I'm going to create one relationship from here, from weather to date, based off the date ID. That one's there. Now, I want to relate this weather data to the pickup geography dimension because it's geographical data, right? And the pickup geography dimension comes from a dimension table in my data warehouse, and it's very common practice to have a surrogate key and a business key on the dimension tables in the data warehouse. And naturally, my weather data coming from Azure Blob storage is not going to have the surrogate keys in it because they're private to the data warehouse and they're generated by the ETL or ELT process for the data warehouse. So in previous compatibility levels, this was practically impossible to do. But now with the 1400 compatibility level and Power Query integration, I can perform a lookup to the data warehouse and get the surrogate key. Right? So I'm going to click on partitions for weather, switch over to design view, and I need to quickly enter some credentials here. Just give me 1 second. And we also need to enter the key for the blob storage, which I need to type very carefully. You see my typing skills are so fast, I don't even need to touch the keyboard. And there we go. And now we want to combine merge queries. And this is really straightforward in Power Query. And our lookup table is the geography table. We'll do the lookup based off business key. We need to specify the privacy level, which affects query folding and query performance. And it will tell us how many matches it finds. It gets a full set of matches. OK, so we've got this new column. And we can tell it that all we need is the geography ID. And there we go. Simple as that. We've just performed the lookup. And this is something that, as I say, was extremely difficult in previous compatibility levels. So I'm going to go ahead and import. This will just take a second. And then we'll be pretty much good to go. I just need to set the relationship based off the new surrogate key. And I'm going to do a little bit more decorating the metadata of the model before we go ahead and deploy it. All right, there we go. And so now we should be able to find the geography ID column here, and we should be able to just drag this down here like this. And we're good. So we're almost ready to deploy. What I want to do just before I deploy, because naturally this is running in my workspace environment here in SQL Server Data Tools, it's local. I need to then deploy it to the massive server with the 10 billion rows, right? Before I deploy it, one last thing I want to do is for this average precipitation inches measure, I want to decorate it with a detail rows expression, which is also a new feature in 1400 compat levels, which is exclusive to analysis services. So I'm going to go ahead and super fast typing skills, I know. And so what this detail rows does, and by the way, this thing has full IntelliSense, and detail rows allows the business users to drill through from the aggregated cell value down to the individual transactional records behind that aggregated cell value. It's currently only supported from Excel pivot tables. Hopefully it will be supported in Power BI in the not too distant future. So we anticipate that the majority of these detail rows expressions that are just a DAX table valued expression will be based on the select columns function, which is a very simple DAX function. In this case, the user will be looking at the precipitation inches aggregated value, and we'll then drill through to the individual weather readings that contribute to the aggregated cell value, right? And here we can specify column name aliases, we can pick columns from related tables, etc. Really straightforward. So we'll go ahead and apply this. Okay, So we're basically ready to deploy now. Let's go ahead and save this. And in order to deploy, I'm going to use BISM Normalizer again, because it's not just for bridging the gap between self-service and corporate BI. It's also a deployment tool, and this will be an opportunity to discuss deployment methodologies for tabular models, because this is another key difference between self-service and corporate BI. For corporate BI, we're typically going to have development tests, maybe user acceptance tests, and production servers, and we need to deploy the solution through the environments and get it tested in a rigorous way. So instead of selecting tools, new tabular model comparison, this time I'm going to double-click on the BSMN file, which has all of the comparison information stored in it, which includes all of the options, it includes the source and target models, and it even includes the individual skip items. So I can use these BSMN files kind of like configurations for deployment to each environment. I could have, for this one model, I might have 3 or 4 of these, one for each of the environments I'm going to deploy to with all of the settings. So maybe my production environment, I don't want to mess with the roles because that's got different members in, so I just have that skipped ahead of time. Another thing I can do, I'm going to quickly call out, that I can run this from the command line. If I just open up, there it is. I can run this from the command line, and the only real parameter here is the BSMN file, because it has all the information that it needs. What does this mean? This means that this is fully integratable with automated build and deployment processes for integration with DevOps and CI/CD processes. All right, I'm going to do it from Visual Studio this time. I'll go ahead and perform the comparison here. So as I say, everything's pre-selected for me. So I'm going to take a moment to talk about deployment methodologies for corporate BI models. There's basically 2 schools of thought. And we had a kind of similar discussion in the integration services community over the past few years. So the traditionalist camp likes all or nothing deployments, which absolutely you can use BISM Normalizer for that. So you package up the whole model from your development environment, and you deploy it through test and then production. If you're going to do that, you normally need a production branch for bug fixes, right? It's the only way you're going to get a bug fix to production quickly. If you have a production branch for bug fixes, that means you're in the realm of branch management. That means you need to do branch merging. There's only one way to do a merge for tabular models, and that's BISM Normalizer. So you can use it for all or nothing deployments and branch management. However, there's a second school of thought, which is that it's okay, given the impact analysis that we get with BISM Normalizer, and given that tabular models are fairly well structured compared to, say, multidimensional that have a bunch of interdependencies, it's okay to deploy individual features through the environments. Like if I need a bug fix, I'll just script out the measures that I need, and I won't include everything else that's in my development environment that's not ready to be deployed, right? And then I don't need to manage branches, and I get the extra agility to respond to business needs, okay? So we've got these 2 schools of thought. Either of them, you can do either of them. I'm not advocating for one or the other. In this particular case, I'm going to be doing an incremental metadata deployment. So let's go ahead and hide skip objects to focus on what we're going to actually do. So we've got the Azure Blob data source that we're going to push through. We've got a couple of M expressions here. And I've also got this security table, which we haven't talked about this one yet. And this table, in conjunction with the user table, is used for dynamic row-level security based off this role. So this role here has a row-level filter that's based on the current user's username. And there's another item here, which is this role is setting up what we call object-level security or column-level security to protect the medallion business key column. All right? So this is another kind of enhanced security feature that you only get in analysis services. And this allows me to secure not only the data, but also the metadata of the model, so that an unauthorized user cannot even discover that there is conceivably some column in the model called business intelligence or medallion business key, let alone find the data in it. Right? And so these medallions, they go for like $1 million on eBay. And this, I'm assuming, is the license number. So this is sensitive information that we want to protect. Right? OK, let's see what else we've got here. We've also got the trip table. And the trip table is the one with 10 billion rows in the target. And so this is another very common scenario when we're deploying a corporate BI model, which is, if you look at the partition definition for these, the version that we get from source control, which is what we've got in Visual Studio, has only got one partition, which is filtered on the top 1,000 rows. As I said, this workspace environment is running locally. I don't have 400 gigabytes of memory and 32 cores. Maybe the Surface Book 2 will have that kind of spec. We'll see. I don't know. Currently, I can't do that. And either way, it's a best practice to create and manage partitions from another process, which we're doing from Azure Functions, right? So therefore, the version that we have in the target has got 120 partitions or so. So we need a way to deploy this new model metadata and not mess with all the partitions in the target, right? So using BISM Normalizer, there's a couple of ways we can do that. We can just right-click skip, which is what I'd already done. That had already been persisted in the BSMN file. And as of recently, we can also, even for a table update, like if we're going to add some display folders to some columns or something like that, we can still retain the partition definitions and thereby retain the data. If we deploy the partition definition that we have here in the development environment, those 10 billion rows will just evaporate into thin air, just like that. They'll just be gone. That's a critical deployment feature, that we can retain partitions in the target. And then I've got a bunch of measures here, which for whatever reason, I'm not ready to deploy these. So I'm just going to select them all, right-click, skip, simple as that. I'm doing incremental metadata deployment. I don't need to deploy everything, right? So we'll go ahead and validate the selection at this point. No warnings, so we're pretty good. We'll go ahead and update the target. And here's where I need to be really careful and type this in correctly. And I need to specify the privacy level for Power Query. As I said, this affects query folding and query performance. And we also have the blob key. There we go. So far, so good. All of the issues I've had preparing for this were just fat finger typing issues, which is why I'm being so careful. All right, and we'll specify organizational. And at this point, it will take the configuration information from the options that were stored in the BSMN file, and it will detect only the tables that need to be refreshed. So it's saying there's only 3 tables that are being created or updated. I'm not going to bother refreshing everything else. So it's doing the weather one right now. So it's actually performing the lookup to the SQL data warehouse to get the surrogate keys and integrate those values. So it's done there. And now we'll refresh. And we've basically got the same model in the source and target at this point. And I'm now going to browse the model, but this time I'm going to do it from Excel. So if I refresh here, we should get the weather measures show up here. Just give it a second. And then, where are we? Let me just give me a bit more room here. There's average precipitation inches. We'll drag this down here. And I can now, so as you can see, this was the 10 billion rows. And I can now double-click on one of these cells, this is the aggregated value for all of New York for June. And I can double-click on one of these cells, and it's going to invoke the detail rows expression, and it will show me the individual weather readings that took place in the whole of New York, but here it will break it out by county and zip code. And you'll notice that it's only showing the weather readings that took place in June of 2010. Because it automatically inherited the filter context from the cell that I double-clicked on. And if you've ever done this in multidimensional, because multidimensional has the default drill-through action and row set actions, and if you would often have to revert to row set actions to get the more advanced behavior like column name aliases and concatenated column names and overriding filter context and stuff like that. So, and in row set actions, it did not automatically inherit the filter context, which meant you had to inject it into the query, which was a complete nightmare from the maintenance standpoint. This is super easy, super user-friendly. It's actually a more powerful and easy way to do it. This is an example of how we've learned. If you know, Analytic Services has got 2 modes, tabular and multidimensional mode, and multidimensional is very popular. We may well be putting it in Azure. This is one of the things that we've got a chance to learn from how we did things in multidimensional, and I think it's fair to say that it's actually better in tabular, right? If Chris is nodding, then I've got approval that it's actually better. So thank you. All right. So that's the detail rows, and I'm now going to switch over to another Excel file as soon as my virtual machine catches up. And here, I'm impersonating a user who is a member of that role. So as you can see, this user cannot see all the 10 billion rows. This user can only see the taxi rides where the pickup location was in New Jersey. If I look for the medallion business key column, you can see that it's not visible. This is because of the object level security or the column level security. And object level security is more than just like perspectives. If you're familiar with perspectives in analysis services that will hide the metadata from the field list, object level security actually secures the object, right? If I run a DAX query on the model and I explicitly reference medallion business key and I'm not authorized to see it, it will act as though the column doesn't exist. Even if I reference a measure that is in the model that then references medallion business key, that measure will be indirectly secured and it will act as though that measure doesn't exist either, okay? All right, so I think we're basically done here. Let's see how we're doing for time. I think we're in good shape for time to have some questions as well. So I'm just going to summarize a couple of things here. What we saw fine-grained partition management through an API that is scheduled from Azure Functions, maintaining an end-to-end platform as a service architecture, which then enables these massive models with 10 billion rows and super fast interactivity at the speed of thought. Right? We saw BI schema compare for application lifecycle management. I'm not aware of another BI vendor on the planet that has schema compare for business intelligence models. We saw deployment methodologies, for which there are two schools of thought, all or nothing deployment or incremental metadata deployment. One typically requires branch management. The other one allows you to deploy individual features through the environment. We saw enhanced security with object level security and enhanced modeling with detailed rows. And some other typical features that I did not include in the demo are things like enhanced monitoring to figure out how long processing is taken, if there's any blockers in processing, long-running queries, and which tables in the model are actually being used more frequently than others, and enhanced calculations are also a typical feature for business intelligence models. And this is my further reading slide. I would like to call out this Power BI Governance and Deployment Approaches white paper by Javier Guillén and Melissa Coates. This covers this bimodal BI concept in a lot of detail. Strongly recommend it. And that's the Microsoft Analytic Services Git repo that has the code sample for the automated partition management. Look me up on Twitter. I'd love to hear from you. So thank you very much. Hopefully this helped compare and contrast the two worlds of self-service and corporate BI, and highlighted that we can actually bridge the gap between these two worlds. They don't have to compete with each other, and Microsoft is uniquely positioned to do that. Why? Because Power BI and Analytic Services share the same engine. Simple as that, right? That's why we can do all this stuff. So thank you so much, and we'll open it up for questions. Cool. Thank you. Appreciate it. Cool. Do you want to go to the microphone, sir? Thank you.
Yeah, first of all, great presentation. Thank you very much.
Appreciate it.
Now, what would you suggest if the corporate BI is in the multi-dimensional, stack? What roadmap we should take it?
Sorry, can you restate the question? Yeah, you're in the MoLAP stack?
Exactly.
Okay.
Yeah.
So if MoLAP is working for you, great. There's no issues. We'll be confirming later whether we're going to get MoLAP into Azure. And if you want to do a lift and shift and it works for you, and especially if you've got some features in MoLAP, like for sophisticated calculation scenarios that aren't supported in Tabular right now, and you want to wait for Tabular to catch up in those areas, you're welcome to do so. If you're starting a new project, then you probably would want to consider Tabular more aggressively, given that we use the analogy that MoLAP is like a mature product that doesn't need to be nurtured as much, whereas tabular is getting more investment because it's still being nurtured, so to speak. So, for a new project, I would consider tabular more heavily. For an existing one, if it works for you, then, stick with MOLA. Okay? Yep.
Oh, yeah?
Cool.
Okay.
Cool.
Hello. I have one question. Will we have the ability to import Power BI model in SQL Server 2017?
Yes, but so a couple of things. We expect to have import from Power BI Desktop to show up in SQL Server Data Tools and SQL Server Management Studio, right? And then you would just import it straight to SQL Server Analysis Services 2017 model in Management Studio or to the workspace in SQL Server Data Tools. And in the meantime, you can get it to Azure Analysis Services exactly the same way I just did. And then you can integrate that into, when I integrated it into SQL Server Data Tools in Visual Studio, this is the modeling environment in Visual Studio doesn't even barely know where I'm going to deploy this model to, right? It's a symmetric modeling capability, between SQL Server Analysis Services on-prem and Azure Analysis Services in the cloud. So once I got it into SQL Server Data Tools, I could deploy it to anywhere I want, right? Yeah, okay,
Thank you very
cool.
much.
This was very informative. Thank you.
You're welcome.
You showed direct query here with obviously lots of data, but what are some of the levers for direct query versus instantiating cubes? Kind of considerations.
Yeah, so I'm going to rephrase the question, restate the question. So I think you're asking for when would I use direct query versus a cached model?
Yep.
Okay, so I would typically use direct query if there is maybe too much data to fit into memory, even though we can support, on the big S9 servers in Azure Analysis Services, which is 400 gigabytes of memory, I can have 10 billion rows, about 9 terabytes of data. However, in some cases, I may even have more than that I just can't fit in, right? And then there's no other choice other than direct query. Or if I have some near real-time refresh requirements that make the data load into memory too expensive to manage. We acknowledge that it's a very binary at this point. We would like to kind of get the best of both worlds, be able to have selective caches on really big models and have subsets of the model for near real-time scenarios that that come from the source and other parts don't. That we may or may not be working on that. No announcements at this time, but we acknowledge that that's an area we would like to improve on. So, but at the moment, it is either the volume and freshness versus the query performance. There is, as far as I know, there is no other BI vendor on the planet that has the performance of once you get the data into memory. The blazing fast interactive performance, that's what really enables the clicky, draggy, droppy data analysis. Okay? All right.
I have a question. So
Sure.
how much of this is going to be available not through Azure, but just SQL Server 2017? Are there parts of this that
Basically, everything I showed is going to be available in SQL Server Analysis Services 2017. The only part that may take a little bit longer is the previous question about getting it to import from PBIX into Analysis Services. I need to put that into Azure for now. As I said, it will probably come in the not too distant future straight into SSDT or through SQL Server Management Studio. But in the meantime, that's the only bit that isn't going to be supported in SQL Server Analysis Services 2017. It's really a symmetric offering between on-prem and the cloud in terms of all of the modeling capabilities. Once I got that model into SQL Server Data Tools in Visual Studio, it didn't, like I said, I could deploy that same model to wherever I want, right? And all of those features are supported in both. Yeah. Okay, cool. All right, you're welcome.
I had a question about the Azure Active Directory B2B.
Yeah.
And how that relates to the object level security.
Yeah. So if you notice, when I deployed this model,
Yeah.
there was only one role member in there,
Yeah,
and
that's
it was
what
an
popped out
Active
at me.
Directory. It was an Azure Active Directory UPN, like an email, rather than a Windows Active Directory login, right? Because at least in the current version, if I need to have all of those. This is the biggest difference, really. In the modeling environment, it barely, like I said, it barely knows where it's going to deploy the model to.
Yeah.
But that's the only kind of noticeable difference is that the security members are either going to be Azure Active Directory UPNs or they're going to be Windows Active Directory logins, right? And then once you're deploying to Azure and it's an Azure Active Directory UPN, then you get all of the Azure ecosystem and the Azure security infrastructure with Azure Active Directory and the B2B, and you can synchronize from on-prem to Azure Active Directory, et cetera. Yep.
Yeah, so like when you're doing your drop down there and you're like had to pick the sort of the security level and you're picking organization.
Right.
Would that, like, so your external users, would you be able to segment them to be like
so that was that privacy level.
Yeah, the privacy
actually
level, yeah.
there is lots of documentation on that from the Power BI side, because that is something that we introduced to 1400 models once we introduced Power Query, which has been used in Power BI for a while. And so that privacy setting is going to affect query folding. So for example, in this case where I was taking the zip codes from the Azure Blob data source, and I was performing a lookup to the data warehouse to get the surrogate key, and it generated a query. If we'd run Profiler on the data warehouse, we would have seen that the query just had all of the zip codes it wanted to perform the lookup for, and it folded that query down to the data source and got much better performance. If I was to say that data source was private, and I did not want to allow people to run Profiler and detect, let's say the zip code values were sensitive or something. I didn't want those folded down to the data source for the query, then I could have set it to private and it would have stopped doing that. Kind of like a security feature. But yeah, and again, that works exactly the same as it does in Power BI.
That's great. Yeah,
okay,
thank
cool.
you. Thank you very much.
Any other questions? Go ahead. All right, yeah, you're welcome. Thank you. Appreciate it. Thanks, guys. All right, cheers. Thank you very much. Appreciate it.